Good
We're
morning. It's
live.
Thursday.
Good morning. It is Thursday.
Good morning.
And we've got a special guest with us today. I don't think I've ever actually met Rachel before, so let's give Rachel a warm welcome. Rachel, could you say a few words about who you are and where you're coming from?
Yeah, well, it's not morning here. I'm in Berlin, Germany. So I'm Rachel Appel. I do web stuff, a lot of ASP.NET, JavaScript, basically anything on the web. I've been in the business for like 30 years now, doing programming. I started back in the days of COBOL and all that good stuff. Worked at all kind of places, at least half of that time as an independent consultant, and other times working for companies, including Microsoft, and now I'm at JetBrains. So, because they got the visa for my European residency and work permit. So, also a very good company. So, I like working there.
Cool. And I understand you're a developer avocado with them.
Yep.
I love those little emojis that just kind of tell the story. About
yeah. Tasty green fruit or vegetable. I'm not sure what it is, but
oh, cool. We'll take it. That sounds like quite the career. You said 30 years, and I've only been doing software engineering stuff for like 10. So that's incredible for you to have like 3 times the world experiences. And can you speak to that a bit more? Like after 30 years, you must have seen so many more things than I can even imagine.
Yeah, so I've seen enough stuff, and some of it is just so ridiculous. I mean, I'm pretty sure Cam's heard half of the rants about certain places that I've contracted or worked at, and so much so that you tell these stories over the years. And then I said one day, you know what, I'm gonna make a talk about this. And so I did, and I called it "It Works on My Machine." Right? Because a lot of this comes down to that line, and it's just utter failures, from tiny things that aren't a total failure to some of the most imaginable horrendous disasters that are out there in software engineering. So it's kind of a hilarious don't ever do this stuff talk, and then of course giving an alternative of what you can do instead. But yeah, I've seen everything from one of the things was a person who deemed himself as a SQL expert insisted that you take a SQL server tables, and you shouldn't have multiple columns in it. You should only have one column in it. Inside of it, you determine where the characters start and end for each field. So you essentially do a fixed width file inside of a single column in a SQL table.
Oh my God.
And then this person was utterly confounded about why you couldn't index it and why queries took so long, and the stored procedures had to constantly, it was just pat index, car index, ltrim, rtrim, just a bunch of substrings and stuff like that. And this person was actually confounded as to why it didn't work well. And I'm like, well, you just tried to recreate an ISM database with a relational database with an engine that's optimized to do the exact opposite, and that's exactly why. Well, and then he tried to say that the SQL team told him to do that, and I said, well, I happen to know people on the SQL team. Why don't we call them an ass? He kind of shut up about it after I said that. He said, well, we gotta wait an hour till they kind of get up and roll into the office, but we could call them, right?
Oh my God, that's amazing.
He wouldn't have nothing to do with that. So
that's a great story.
But I've seen stuff like that were just mind-blowingly awful. And the funny thing is, sometimes when I add this story into a talk, I don't think I need to tell people no, one column in SQL Server is not the answer. But somebody actually did come up and they're like, so what would you suggest?
Oh,
I'm like, more than one column.
Maybe throw some indexes in there somewhere. I don't know.
Yeah. So good times. Somebody else at the same company. So this company was just riddled with some of the worst dysfunction I've ever seen. They were a company I would say succeeds despite itself. And in the early days of .NET, they had a web forms application. Now, I've seen some really nice web forms applications. Like, I know people like to poo-poo web forms, but I've seen some really nice stuff out there. If you create patterns that work and you apply them consistently, you can work with web forms. Technically, this person did make a pattern, and it was consistent. It was just like one of the mother of all anti-patterns, which was one default.aspx page. Inside of that page, one content placeholder. And this was the framework for the whole app. And the code behind was like a 200,000+ line code behind. And all it did was controls.add to that placeholder, and then a bunch of if-then statements based off of what was in the query string. So if people logged in, it would just pass over their username and password. It would hit a SQL database, and it sometimes had to work with that SQL database that had one column in it. So that made that application even more fun. And then it was like all these lines of code that just like built the page, and I'm like, congratulations, you just did what ASP.NET does, except you did it suckier. What do you think they're doing when you add controls to the page? That's what they're doing, and now you're doing it again, and you're doing it in the most stupid way possible. So.
That's incredible. We're going to transition over real quick to our checkup, and I hope that this transitions well, because we're going to talk about a tour of C#.
So now I'm wondering if a view state doc would have been more appropriate for the checkup segment. Web forms, view state.
Web forms, it could have been. That could have been one of the things we did. Trying to see here. Solo, let's lay this one. All right, so for today's doc, we're going to focus on a tour of C#, and this has been recently revamped by our good friend Bill Wagner. And I think this actually corresponds pretty well to the topic that we're going to have as part of our hallway track today. So being that it's a tour of C#, it really guides the user through their first introduction into C#, the language, and it kind of holds their hands even to the point where it's saying, here's how you actually pronounce it, right? We start off with C#. It is pronounced C#, and hopefully this is the last time you'll ever have to see that correction about C#. But
what about C hash?
C hash? Well, I mean, that's an option. That's an option. I mean,
I've also heard it referred to as a reverse hashtag.
It's many things.
That's not C Octothorpe.
That's what we'll name it. We're going to rename it just for you, Rachel. But this doc is pretty powerful because it actually walks you through in an interactive format. So if you actually hit run here, this is leveraging try.net. And if my machine will work, wait for the poor internet connection. It's actually going to spin up a kind of focused mode where you'll have an interactive REPL within the browser that puts the code in there, and then you can run this, of course. But once it runs, it'll have the output down here. Wait for it. I have it. Luckily, I've got it back up. Ta-da! And then we can actually change this to be whatever you want. So hello, guests on the show today. And run it, and you'll see the output. And then this is a great way to like interactively kind of learn some of the constructs of the language. And it's a great way to, get acclimated. And luckily, this isn't teaching people how to manage view state and web forms and stuff like that. Or, I've seen actually SQL REPLs before, and I don't think they've ever said use one column or a single column. But
this is actually really nice for those cases where you're lazy like myself and don't want to fire up Visual Studio to test something out. You can just do it in the browser.
Kind of reminds me. You remember what was that? What was that thing? It was something pad, so C# pad, something.
LINQPad.
LINQPad.
Yep.
Yep.
Not to be confused with LeapPad, something my children use.
My children used it. It's been around for a lot of years.
So cool. That's the doc.
So I used to work for the company that brought LINQPad to people.
No kidding.
Yeah.
Out of curiosity, which company is that?
Well, so I worked for a company that owned them, so I didn't work directly for the LINQPad people. And that company's out of business now. But it was called Productivity Point, and their parent company owned them. So.
Cool.
So the cool thing was you could get like free LINQPads and stuff like that, or super discounted products.
See, that they should have made productivity apps for them.
LeapPads with LINQPad installed. It's the ultimate productivity machine for kids. Should we transition over to our hallway track and
Let's
start
do
the
it.
conversation with Rachel?
Let's do it.
As soon as your producer can find the button. It's one of those mornings.
Press the. I feel like after the introductions there and like the checkup, like there's already been so many good nuggets. I wish the entire show was just the hallway track so that we could have boiled this all into that. But you've got a really interesting subject for today's show, right, Rachel? You wanted to talk about, as I understand it, software engineering, but for a product line specifically, and you can liken that to like Visual Studio or other things. And then you actually wrote a thesis on this whole concept, right?
Well, I'm in the process of writing the thesis on it now.
Interesting.
So there's what I'm working on is something called software product line engineering, which is not, it's somewhat esoteric. Companies are using it, but it's not like a widespread development methodology. And it really probably should be, because in one form or another, people are striving for this. And what it is basically you have many products, and we want to be able to reuse code and assets, right? Reusability is one of those holy grails of software engineering. And this takes reusability to the highest order that you can, right, at the entire product level. So if you consider like Visual Studio or take the JetBrains product family, we have IntelliJ as like our first and foremost product. And that is the basis for the IntelliJ platform, which has a set of shared UI components and a shared set of API components as well that are done through microservices. And then we have a whole bunch of IDEs. We have RubyMine, CLion, Golang. Now these are very different languages. Rider, ReSharper. Now ReSharper, set that to the side for a second, but we have WebStorm. I'm even missing a few, I think, DataGrip. So we have everything from these different language IDEs all the way to stuff like DataGrip, which is working with databases. And they're all built on the IntelliJ platform, right? So it's a Java-based JVM platform product. So if we're building all of these things, and people notice right away, they're like, oh, there's a common look and feel. Well, yeah, there is to many Windows apps and Office and Visual Studio and stuff like that. But ours is also because we're actually just reusing a lot of the code. So we've engineered it in such a way that you have a plugin model that allows you to have these two core services, and then literally everything else is kind of a plugin. Entire products could be a plugin, which is pretty cool. And then you have things like Android Studio, which I think Google created, and they just basically reused our stuff to create the Android Studio, which would be a plugin, and then that turns into an entire product. On the .NET side, you have ReSharper. Now, ReSharper is an extension to Visual Studio. So that can use things like the microservices and whatnot from IntelliJ, but it does have to adhere to Visual Studio. And then we have Rider, which is the .NET IDE, and that actually uses resources from ReSharper and from IntelliJ. So we actually have like these crossovers of reusability between our products. But if we were to rewrite individually each of these products, or even to have a small set of shared library that you shared through like NuGet or some kind of package management, it would not be the same as an architected family of products. So there's some methodologies out there, like one is called Pulse, and it's, product line software engineering, it stands for it. And what it does is it takes, you model these commonalities, so things, if you look at even Visual Studio, should have some sort of modeling like this behind it, between different editions. So you would have a core set of features, and then those cores are shared across multiple products. And then from that, you then do what's called variance modeling. And you say, well, Visual Studio Community does not maybe allow you to do stuff with Team Foundation Server, right? So the enterprise version would do that. So we're going to variance that feature into the other product. Or for us, it's entire languages, right? So Golang works with Go language. So that's a variance. And Writer works with .NET. But Writer also includes WebStorm in it, right? So you can also do JavaScript. So you can do your ASP.NET programming and anything for the web in there. So we're taking a lot of commonalities, making sure they're shared properly, and then having the variances, which are the features that you don't need to reuse that are per product. So it's all about modeling that. And it even goes as far as, if anybody even remembers or knows what the heck this is, CMMI, right? Which is that like really old, like from the days of Rational Rose and that kind of very formal modeling, and the capability maturity model, which really the only people doing that stuff are like Boeing and Raytheon and, stuff where if the software doesn't work, people die, right? That kind of stuff. Those are also modeled if it's in with stuff like that. But you don't have to use stuff like that because most people don't anymore, except at places like Boeing and stuff. And Boeing is actually one of the canonical examples when you talk about product line engineering, because airplanes, right? They're not reusing software. Right? I mean, they are reusing software. They're not rebuilding new software for each plane, or you would have a lot more crashes and a lot more horrible accidents and things. Once you have a core set of things that are tested and they work well, we don't want to, just throw those out and have to rebuild them. We want to be able to reuse them. So you have that. And then also, as your software evolves over the years, right, updating stuff and maintaining and doing the legacy code and fitting that in. So you do have to work this into your domain model and requirements architecture and all of that stuff. So that's like the gist of it. So what it's not.
I was going to say that's fascinating.
It is really cool, and I think more people should do it, because even so, you think, oh yeah, well, Boeing and Raytheon or Nokia uses this for their phones. Actually, look at any phone that has an evolution of a line, right? A version 6, 7, 8. Look at iPhones. They're doing stuff like that. I haven't actually seen any literature on Apple products, but I'm pretty darn sure this is what they're doing. But what this is not is just small little package reuse. Oh, cute, I wrote a component and I'm sharing it with friends, or I wrote a small little API or something. No, it's not a single product. It's not just standards. And it's not necessarily service or component-based development, but it is architecting an entire line of products. So normally people think of products as a single individual soloed thing that they architect. And then we find out that even small companies can benefit from a product line, especially when you probably run across this in your career at some point. You build a piece of software, even if it's for internal usage at a company. And one department will use it, and then another would say, but I would like this little thing. But only that other department wants this little feature, and the rest of them don't. And then you might end up branching off and doing feature branches, and then that might get out of control sometimes. I've seen this happen at various companies where they've had feature branches all over the place, and they couldn't quite control it. And then they had these merging nightmares when it came back at the end of trying to merge it into one product. So what they're trying to do is keep that all encompassed into one product to rule them all, with all the features that are maybe turned on and off for this customer or that, when instead we could architect them out as a line of products and manage the features that way.
So out of curiosity, you touched on something that I was actually very, very curious about. You mentioned having this one like external department that wants, feature A that's not part of like the core service offering. So how does that actually work? Like if you have this core service offering and it's got all these contracts or APIs, and then there's extra bits outside there that want to have their special thing, like what's the appropriate way for them to get that functionality?
Right. Well, so that's one of those, it depends. So there's various ways to do this. Now, if you look at actually the way JetBrains is doing it, we're not doing it the same way that the academics have written and described doing it, which is part of what my thesis is about, is saying like, hey, look, here's what the academic literature says and what the practices have been that you see at places like Boeing and stuff. But then you have certain companies that are kind of going on their own, and they've come up with interesting and unique patterns to solve these problems. So for us, it's a plug-in model on top of that core and API. For others, it might be different ways of taking, like a common set of features and then working components into there, or certain sets of component libraries. Often plugins actually are a really great way to do this. Or you don't have to call them a plugin. It could be an extension, or you could call it a component. What you call it isn't so much the big deal. It's just that you find a certain pattern or way to work these out according to the way you like to engineer products. So it is kind of Wild West in the fact that not many people are doing it. So there's not, it's not like saying, well, you have waterfall, or something that has kind of like strict rules and guidelines around it. There are some, but there's many more people doing these interesting and unique things and patterns that they create with little extensions and stuff. But yeah, kind of extensions and plugins tend to work, I think, very, very well.
So Rachel, you had started off your answer here with the phrase, it depends, which I appreciate.
I know.
So thank you for saying that. But that led me to another question I have, which is, how often do you think in the real world academia is ignored? We live in this world where a lot of folks are self-taught. They don't have that formal computer science education to lean on. And I think for that reason, academia is often ignored, and teams will just do things the best way that they know how to do them.
Right. So this is that perfect segue into that part of the show about education, isn't it? So yeah, I think so. This is really interesting. So now that I am European, right, living over here for a couple of years, and from my travels around the world, there are things I notice. USA is still kind of Wild West about certain things. And now when I started 30 years ago, I actually did start in a bachelor's degree, but I had no money and I was like just too poor and stuff. And so I couldn't finish it. But I was able to get by because a degree for pretty much anything was important back then, right? And including this new interesting field called computer science or programming. So not entirely new, but like new enough that universities were just starting to really put programs in place for it. And so I didn't finish, but I was able to use I'm going to school and working on it on the resume in order to kind of rise up and get enough money. And then I got to a point where I was getting paid enough, and then I was like, F school. Look at me not cursing. So
thank you. We appreciate that. Would you mind teaching your ways to Krista Mars?
Oh, if I knew somebody else said stuff, I would. All right. Anyway, but I was like, forget that. And then for a while, I was just happy doing. I'm like, you don't need a degree. Throw everything out the window. I always wanted to have a degree, though, just to have the pedigree of having one. That was not just random general studies or something like that people pick on people. So I did go for basically 30 years without actually finishing the degree, right? And then I decided, well, I'm going to go back. But I didn't go for my bachelor's. I went in to go right to a master's, and they accepted my work experience in lieu of having a bachelor's. So there's
What-
a couple things I noticed between doing this process in myself and traveling and living in other parts of the world. Other parts of the world, you do need a degree. Like here in Germany, you may have heard of some certain German stereotypes, and some of them are true. They like people to be educated here. And their degrees often come with an apprenticeship. So you would actually, from day one, you get placed at a company and you are working on software and you work for a little bit, take courses, work, take courses. I think this is an excellent way to do it because you are getting like the actual hands-on skills that people say you don't need a degree for, but you're actually getting the things in the degree. And people do poo-poo and ignore academia, but there are quite a few things that I've noticed that are kind of important. And that's that there are things people are not going to pursue on their own. I don't care what you say. I've heard it all, but you're just not. And I'll tell you what, for one of these for me was AOP. For years, for 15 of these 30 years, I said, oh, yeah, I am totally going to like read up on this and get well acquainted with AOP. This looks really interesting. I said that 15 years ago. And guess what? Until I started this degree program, I did not actually do that, despite saying it, right? So that's a for example, but I see this with other people. Stuff that, I hate to say there are certain things that you should know, and I'm not talking about linked lists or certain algorithms, but there are certain just general things that people should know that I think that they often don't.
So are you like for example, are we talking like basic computer science concepts like a bubble sort, or are you talking more I think software engineering specific, like industry stuff, like how things work?
Yeah, I think more of the industry general stuff, like, you know, like what is a procedural language versus OOP versus functional. You don't need to know details, but just an overview of this stuff, right? And I know a lot of people that don't even know there's a paradigm outside of OOP, right? And things like that. Now, another thing that people tend to do is they tend to think programming and software development is software engineering is computer science. And it's not. At JetBrains, I'll tell you, we are building IDEs. You need to know the bubble sort and the linked list and algorithms and data structures because they're using them in these products every day, right? And for that, you kind of do need a degree. And if you look at most of our company, we have, holy crap, a ton of like PhDs and stuff, and it's all in comp sci. It's not a history major we're talking about. You know, so they do need that because they're doing actual computer science and or software engineering. So that's why I went back for a software engineering degree. Right. So and another thing too is if you do want to move to another country, right? As I hear so many people from the U.S. going, "That's it, I'm out of here," right? Well, you might need a degree to get that visa or a blue card, right? Because there are a lot of companies that won't take you. It's not just the U.S., but a lot of places actually want educated people who are not going to mooch off their systems and can hold themselves up, right? Imagine that, right? It's not just the U.S. Everybody wants productive people in society, right? They don't want moochers.
So if we just get back to your point about, you know, we were talking about the bubble sort. I'm willing to guess most people don't have a clue what the bubble sort is and would Google that. I'm guilty, right? Now, I think where the disconnect here is you go interview for, let's say, a software development job for an insurance company, and they're firing all these hardcore computer science questions at you, none of which are actually relevant to the job you would perform at that company. I think this is where a lot of the frustration stems from in the industry.
I agree 100% there. That what they're doing is they want us, if you're going to an insurance company, probably, unless you're doing some kind of like freak 3D modeling or something, right? Modeling crashes or whatever. They probably just want a software developer, right? And I've actually done some programs for insurance companies over the years, and I've never needed engineering or comp sci skills. So yeah, when they're asking stuff like that, if you're not going to use it on the job, don't freaking ask people like why. It's not relevant. Right?
Precisely.
At that
So
point, you might as well ask them, like how many tons does an elephant weigh and why? Or something. Like it's not relevant either. Why are you asking this stuff?
if my job is to change the color of a button, do not ask me about the bubble sort.
Exactly. Yeah. So, I mean, most of these, even having, finishing up an engineering degree, I don't even remember all these sorts and stuff, right? So you still might need to look them up. But nonetheless, that's the thing. Programming versus development, or programming and development versus engineering and comp sci are totally different things. And I think, first of all, people do not make the differentiation. Right. For general software development, I don't really think you need a degree, right? Because you are doing stuff like, forms over data, CRUD development, some business logic thrown in there. But, most of it, you don't need those advanced algorithms. You're not creating new algorithms or needing to know how to tweak them or any of that kind of stuff. Now, if you're at Boeing working on planes, I really hope those people are pretty educated, right? And actually, I've met some of them, and they generally are, right? So that kind of stuff is a little different, right?
So the differentiation here is being distinct about whether or not it's true engineering versus just raw development. Because I know that here in the U.S., there's a lot of people who have been educated from like boot camps and stuff like that. And what you're saying is those are good to a point, but for maybe painting a color of a button, to Scott's point earlier.
I would say those are software development, right, as opposed to engineering or comp sci.
Interesting.
We have some a great conversation going on in the chat here. There's a quote that says, "Never bother memorizing anything you can look up." I agree with that 100%. If I can Google Bing bubble sort, I'm not going to commit the details of that to memory. There's another comment here that says, "One problem I think is the profession itself is immature. Job titles are all over the place, and degree programs aren't consistent."
Yeah, I would chime in with that. I mean, as Rachel was talking earlier about, the differences between just like development and computer science and software engineering. It occurs to me like there's all these different stages in one's career where maybe even if you'd gone and gotten the computer science education, you're not equipped necessarily for that first programming job, right? Yeah. Just like if you have been working as a software developer for 10 years, maybe you're in a position to start learning more about software engineering, and maybe that's when you need to start looking at that education. Do you feel like that has kind of accurately captures like your trajectory, Rachel? Because it sounds like you did a little school, then you did like a whole lot of career, and then you came back and now you're in school again.
Yeah, I mean, and I did kind of start out with the whole wanting to do science and engineering, and then just went into development, and then was like, oh, geez, I don't actually need any of that stuff, right? And yeah, the thing about the titles is, remember when there was like webmaster? Like, what the hell is that? Right? That was an actual title, right?
The master of all the web.
Right. What's webmaster? Like, so what degree or anything is going to get you that? That's like just and now we don't even use that title, right? So there's a lot of things where people just make up titles. Now that's not on the other flip side is like people go, well, you can start certifying people, not like industry certifications, but like actual engineering licenses, like doctors and lawyers and stuff like that. But you know what? I have seen my fair share of incompetent doctors and lawyers before as well. So I think literally nothing in the world for any job is foolproof, where you can't get people in there who do not do a good job or mess things up once in a while. Like, you can actually be very competent, but you can have that epic screw up, right? That happens.
So I'm wondering, at what point did the job title webmaster fall out of favor? Is it the fact that the
just
the
for a time it
technology of the
wasn't
web
clear.
evolved and became that much more complex that webmaster was no longer a suitable job title? What are your thoughts on that?
I don't remember when. It's just that it went away at some point. But I remember it was like totally hot in the 90s. Everybody wanted to be a webmaster. And yeah, that was like the raging thing with the dot-com bubble, right? It was all webmaster this and all kind of stuff.
Maybe
So.
that's why the term went away, because the .com bubble happened, and all of a sudden all these webmasters were out of work and they had to get a job with a different title.
Right.
We have a comment in
Oh my
the
God,
chat
Swami.
from Architect.
Hi, Reggie.
I think back to when I actually had the job title webmaster and what I was doing at that point. I was using Dreamweaver, writing Cold Fusion code.
Yes,
Uh,
I did Cold Fusion too.
Yep. Very different world we were living in at that time.
Yeah.
But so my observation, and I could be wrong, but my observation is the tech of the web has just evolved so much and become so much more complex that, again, the job title webmaster wasn't really fitting.
Not anymore. Yeah, it did get to a point where it was web applications and a lot of businesses using it. It was like, oh, we actually have serious things out here on the web, and
Yeah,
webmaster doesn't quite cut it. We want professional sounding titles now. Right?
We've graduated from GeoCities pages with blinking text to all of a sudden needing to be both knowledgeable of the front and back end of a web application.
Yeah.
Well,
yep.
and I think that might actually answer the question about when did the term webmaster go out of vogue. Is because, I mean, in the early days when we were all learning, okay, how does this thing work? It was all just static HTML everywhere. There wasn't a whole lot of planning that had to go into it, right? Or a lot of functionality. It was just throw static HTML up on a web server somewhere.
And it was exclusively on the web. It was 6 tags and one of them blinked at you, right? That was what you were doing all day, and registering domains, of course. But also, like, if we go back, I think most of these titles are pretty dinosaur-esque now. When I actually started with COBOL, and you would start as a programmer 1 and go to programmer 2, and there was an actual direct line of what you could do to get to management. And then you went to, like, there was all numbered. There was no senior and junior even. It was programmer 1, programmer 2, and some other crap, and then business analyst 1, business analyst 2, and you kept moving your way up, and you went from programmer to a business analyst. And I think very few places, except maybe IBM, uses those titles today. I have not heard or seen of those titles in a long time. So they went away too. And I guess this was very heavily encroached in the mainframe development. So that's where you would see a lot of that.
See, I actually started. I have my career story is completely unusual in a lot of ways. I actually started developing professionally for money at like 12 years old as an apprentice to like this small town computer consultant, and he had done work for, I don't remember who all. I mean, he had been at NASA at one point, and I want to say like HP or somebody. And yeah, those were there was like a definite line, and he was explaining to me, again, I'm his apprentice, so it was his responsibility in his view to teach me about the industry. And yeah, I had it memorized. Oh, you go from programmer 1 to programmer up to programmer 3, and then you become a systems analyst, and then a business analyst, and then so forth.
Yep, you worked up through those numbered tiers. Oh, I forgot about systems analyst. Yeah, it's been a while.
Yeah, and BAs and stuff like that. Yeah. There's still a lot of companies that use that type of terminology around here, and I've always found it fascinating. So I was going to ask a kind of a naive question here about webmasters. Would that be similar today to like DevOps engineers?
I don't think so.
Totally different?
It's people who exclusively did web development. You were just coding HTML all day and registering domains, maybe a little SQL or Access or something, but that was mostly it. I don't think there was enough infrastructure for DevOps. We didn't really have, back then though, if you were doing anything that would be parallel to DevOps today would be managing a build that took all night. Like I remember working for places where we kicked off the build and left and came in the morning and checked it. So, because it had to run all night. As a matter of fact, even for a while, Microsoft had a build process like that for some of their products.
I think I think Windows. I read somewhere that Windows still has like a 14-hour build or something. It's kind of ridiculous.
Probably. I mean, there's like what, a gazillion, billion, majillion lines of code or whatever ridiculous amount. So don't quote me on that as an actual number because they're not even numbers. But yeah, lots of lines of code.
Oh no, we're going to use that as a quote. That's an official quote now.
So I'm wondering, as we discuss, you know, the different stages in career versus different types of computer science education, I'm wondering what do you see could be done differently in education to more align, you know, technology careers with like, you know, education curriculum, because it seems to me like there's a big disconnect there, right? You have people coming out of school who again, going back to the bubble sort scenario, they know the bubble sort, but do they know anything about, you know, actually doing the job?
Right. So here's something, even without a degree, working in the industry, myself and one or two other MVPs locally in Pennsylvania when I lived there. I was on the board of two colleges as a professional advisor for their curriculum. So there is some problems in academia that are just exclusive to academia. And specifically, I would say the US. I can't really speak for other places. But it would be that trying to get new technology in the curriculum is a slow and painful process. Just approving a book needs like an act of academic Congress, right? So stuff like that is an issue. So they cannot, like, you know, technology's moving and they're kind of going like, wait for me. Oh, screw this. I'm just going to take a break.
Yeah. So it seems to me like
that happens.
So it seems like education, like the academic world, I think, is very focused on you know, methodology and building like a peer-reviewed case for everything, whereas here in software development land, we're all like, oh, agile. Oh, that doesn't work. Throw it out the window. Let's go try something new.
Right. The fun thing is they actually do use some agile in academia. So it kind of depends. Like there is folks, like if you're working on your PhD and you're up at that level, they're definitely doing the peer review stuff. Right? And what they want to do is take new things, proof them, get them peer reviewed, and then hopefully that actually makes it out into the market. And this works great for a whole bunch of other industries, but tech keeps kind of usurping academia, and people just kind of start making stuff on their own and jumping ahead and not going through a peer review process. And you don't always need that for everything that you're doing if you're actually building stuff, right? So like when people come out with Agile, well, no, that didn't, you know, you don't have to sit in academia to come up with that, right? So certain things like that. Another thing too is like it does seem in the US that there is a little bit of variance between what's taught. And I think part of it is that slow moving underbelly of trying to keep up with technology, and technology moves too fast. So you end up with a bunch of older stuff that kids need to learn. But there are certain things that they could do that are just kind of core development skills. Things like knowing what a database is, knowing how a relational database works. That doesn't matter if it's Oracle or SQL or whatever. Knowing certain things like, hey, look, here are paradigms of programming languages. Let's just kind of investigate what the most popular 10 or whatever are. You know, certain core things that I have seen, you know, throughout 30 years that have not changed. And something else that I've seen over all these decades is what I call like the giant circle. The stuff, what goes around comes around. Like constantly, it's all the same stuff, just kind of repackaged, and we're doing it again. right? This happens over and over. So there's a whole bunch of core stuff. If you know this core stuff, then it's the technology on top that is the only thing that's shifting. And I think the schools need to nail the core stuff. But the problem is people keep demanding the shifting pieces. And that's where it's, so academia is trying to walk that line of, well, we definitely want your money and we want you to come and take our classes because we want your money. And then people demand the shifting new tech shiny things, and then at the expense of the core stuff, right? And which does not necessarily mean data structures and algorithms. Like I said, it could be, like, why is OOP different than functional, and why might you use it, right? Which now that's going to last you the next couple of decades, knowing that information, and you don't need to know any particular language or technology, right? And that's going to stay with you.
To that point, we threw up the comment a minute ago. Burmashave in the chat pointed out that maybe professional bodies like IEEE need to do more to attract devs and influence degree programs, and I would absolutely support that. The local community colleges here in Kansas City, they have I don't know if they're degree programs or just certificate programs, but they are like college programs specifically designed to, when you get out, you're going to have like an associate's degree and an A+, or an associate's degree and a CISP, or something like that.
So I'm curious, Rachel, do you think there are certain disciplines in our industry that absolutely require a formal education? I ask this because there are certain areas, data science is one that comes to mind, where I think you really do need that solid foundation to truly understand what's going on.
Yeah, so I think data science, so I'm not all that versed in data science. I'll start with that. But from what I understand from my data science friends, some of them say you don't need the formal education, and some say you do. And from hearing this, what I kind of gather is that it's the same exact thing as software development. There may be two aspects of it: data science development and data science engineering and actual science. Like, if you need to know those under the cover algorithms, you're probably going to need that formal degree. But if you're just going to run the stuff and do what would equate to software development, maybe you don't.
And if we drill into that a little bit and focus just on .NET, do you think there's an argument for saying something like there are certain aspects of .NET that would benefit from having a formal education? Say if you're creating reusable components at the same scale that JetBrains does.
Well, yeah, that would be one example. If you're doing stuff like that, or if you're trying to build a compiler or development tools that use a compiler, or optimizations, or stuff like, even, I know a lot of people in the financial sector don't necessarily have a degree, but they're really, really big on stuff like optimizing down to the nanosecond. And, well, I can go and get Jeffrey Richter's book on CLR via C# and dig into garbage collection and, making calls out into the native system and all these little things like that, or even just dumping .NET for C++ or something like that, right? So I could do that. But, it would also be helpful if I knew how to build a compiler, how that worked, because that's what it all amounts to when you're getting to that level of optimization. That also happens to be the stuff that people like building the airplanes and stuff need to know, things at that level, not necessarily how to build a compiler as the exact example, but they need to know certain actual engineering things, right? So in that case, you're, that's what, yeah, so I see what Andy's bringing up. There are people without degrees that do most complicated tasks. That's true, right? And throughout history too, we've also had doctors that do that, and doctors that are crap with their degree, right? And there's been doctors without degree. Yeah. It's illegal now, by the way, so don't go try to be a doctor.
Well, I was just gonna say that, like, for me, I know I started my career a different path. Like, I was like a blue collar laborer, and then I want to do computer stuff, and I went to college, I got my comp sci degree, and I transitioned into software engineering. And I started out as a junior, and I didn't have a mentor. And I know that for me, a mentor was like something I thought was going to take my career to the next level. And it wasn't for many, many years later that I had that. And then that's what kind of helped me along, right? So I felt as though like the education wasn't really like the driving factor. And I'm trying to play devil's advocate here a bit, right? Like, and touch on what Andy had said in the chat, but it's really interesting because I mean, I think the degree is what got me into the field. And then I carried myself and I did a bunch of self-educating things and I learned, and eventually I became an architect and a technical evangelist, and I did all these things, but it wasn't without that mentor that really kind of took my career to the next level. I don't feel as though the education was, or the degree rather, was like the driving factor to getting me doing.
Yeah, I would say probably a mentor. I never had a mentor, so but I would say I wish I did. Right. I do wish there were people, especially when I was starting out there, to say like, here, do this, do that, or, you know, here are pitfalls and whatnot, because I could have saved myself a lot of grief over the years, and probably have actually over time made a lot more money as well, and a lot of benefits to that. And like I mentioned before, the apprentice programs, you know, like degrees outside of the US, you know, I think an apprentice program, if colleges implemented that, basically you get mentorship with that, right? And you actually are working in a guided fashion. So you're learning and you're working, right? So all that stuff that would be self-study is actually eased for you. Because I kind of did the same thing. I mean, sure, I took a couple classes. I went for a year, but then I ended up like doing self-learning for pretty much everything anyway. So.
If I can,
because what I had in college was Turbo Pascal. I never used it or did anything with it or give two squats about it. It's Turbo Pascal. Like, who cares? So,
if I can riff off that just a little bit. So the way I got into the industry, I've really thought for a long time was really ideal, and I wish there were more paths into the industry for people like this. You know, again.
I think we're losing Cam. His signal's breaking up some. Cam, you're dying off. There's a lot of things here in chat, though, I wanted to bring up anyways. I know our good friend here from Twilio, AJ, is chiming in with them. He just keeps putting all these amazing quotes in here. So I'm just going to post a few of these things and kind of riff through these. And Burma is talking about, you know, formal education it's a broader concept than just degrees. And I think that is, you know, related to the whole mentorship aspect of things.
Yeah.
And Scott had mentioned, like, you know, a strong sense of curiosity and hunger for knowledge can take you very far, right? You know, just being hungry. And so there's lots of little things here that are exciting.
You know, another thing too is I want to like just say, you also can get, like somebody mentioned before about, you go on that interview and it's for an insurance company, right? And you're just basically going to be calculating, you know, how much is somebody's premium or something like that. And then they're asking you, oh, well, what about the, you know, fish sort or whatever, like something stupid. And you're like, hey, I don't know this. I'll look it up. Is this even a thing? You know, and they ask you these ridiculous questions. It's, in some ways, it's almost like they do things like that and use certain degrees that are not applicable to the job as gatekeeping. Right, which then keeps a diverse set of people out, right? And you do have issues with a lot of people who are not economically able to get a degree. And I was one of those people, right? So, you know, that's what I said. Like, look, I was one of the people who was self-taught, right? I'm going back after 30 years. So if you don't count 30 years as enough experience to say I've done it without the degree, then I don't know what counts. Right.
But before my internet connection cut out, that's what I was actually trying to say is, you know, I got to start as an apprentice, and, you know, I had, before I even graduated from college, I had, you know, probably about 9 years of actual hands-on experience with actual working code, and even quite a bit of experience with customers, like, you know, hooking up printers and stuff that you know, that no education could have replaced.
Yeah, I had to do that in the early days. You also had to work help desk and stuff like that as a programmer. Yeah. So you did stuff like that, and then hooking up printers and having to know the hardware a little bit more, which I don't know or care about that now at all. Right? Because that's a lot of that's done for you now. I could buy a PC now. I have put them together, but I am too lazy and I don't care to do that anymore. It's a great exercise for people who want to do it, but
so we've got 5 minutes left, and I just wanted to say, typically this is where we have some of our like final thoughts, closing thoughts. So I wanted to ask you a very specific question. Like, if you could tell anyone starting their career, either before acquiring a degree, or having an opportunity to do like an apprenticeship or like a boot camp, like someone very, very earlier on, what would you tell them? What advice would you give them to getting into this industry?
Yeah, find out what it is exactly that you want. You might not know that right away, but sit down and think about it. Do you actually want to do the sciencey stuff? Do you want to go into academia? Do you want to do business development? And like, just try to gauge that, which might include talking to people in the industry. Go out on Twitter and start asking people like us and others, like, hey, what about this? What about that? Try to figure out what you want. Once you do that, then you could figure out, like, is it development? Is it engineering? Is it science? Right? So that you have a better idea. And then get, like you said about the mentor, get yourself a mentor. A mentor and a sponsor, which are two different things, right? The mentor does the mentoring, but the sponsor is the person who can actually introduce you to other contacts, like, oh, hey, here's a job opening. Let me introduce you to this person, which is not necessarily what a mentor does. The mentor is helping you gain knowledge in an area. The sponsor's helping you get opportunities. So get yourself a mentor and sponsor. Get a bunch of mentors, right? And see if you can apprentice or shadow under somebody. Like, just follow somebody around. Don't stalk them. I'm not saying that. But, nicely follow them, legally follow them around and watch them develop. Ask if you can pair program. Like, there's people out there in the industry, a great deal of us are more than happy to sit down with juniors and share all these, trials that we've had to go through to make it easier for the next group of up and coming people. So, just randomly, like most people, you just hit them up. People want to talk about what they do, right? It's a thing. It's called human nature, right? People like to talk about themselves and what they do. Hence, we have shows like this, or this wouldn't even be a thing, right? So
Absolutely.
you just go on Twitter and be like, hey, you're a known .NET person or Java or something. Do you have a few minutes to pair with me? Look at my code. Tell me, how I can improve. Or I'm just struggling with trying to figure out what I want to do. Do I want to be a programmer, an engineer, or something else, right? Or even go off into data science, and how can I hone that? Can you help me? People love to help other people when that's their expertise, right? They are more than overjoyed to do this. Not everybody always has time, but when they do, I find that they actually do help. I'm one of these people who does this. We have the whole like MVP program and Google Developer Experts and other programs of people who are doing this exact thing. So for juniors out there and people just starting, you have, they didn't have Twitter and this stuff, right, that they kids have nowadays. Right, so, like they didn't have that. I couldn't just go ask people, right? I had to actually RTFM. That is how, we didn't have Google. Google wasn't even a thing. GeoCities wasn't a thing. Yes, ma'am, that called. Right, so like I've been around that long now. There was a time where I couldn't Google stuff because there was no Google. So, like you have these things, take advantage of them. Like, I totally wish this was around years ago so I could have just asked people questions. Would have been great. You had to mill around creepily at the bookstore and waiting for people to read the same book you were to be able to do that. It was, yeah.
That's
so like
awesome.
Don't creep around like I had to. Just ask people online.
And then I would second that and just echo everything you've said and say one thing: don't be afraid to ask questions, because there's so many people who feel like there's stupid questions. There's no such thing. Like, ask questions.
No, it's not. Yeah, no, and I'll guarantee you other people want to know what you're asking as well. Like,
Absolutely.
I've never found a question where other people weren't also going, I was wondering this too.
Awesome.
I think so I know we're running short on time, but I just wanted to say it seems for some folks there's this curtain of arrogance that they need to take down. They need to realize, it is okay to reach out and ask questions.
Yeah.
The reality is you don't know it all, and there's someone more than likely that you're working very closely with on a daily basis who can unblock you and push your project forward.
Who's experienced those same, problems, right? So awesome. Well, thank you so much, Rachel. This has been amazing. Great conversation. One update real quick. Next week, our show is Monday. So it's a different time rather than Thursday. Thursday's been our jam for a while. We're going to Mondays. So check us out next week, Monday.
With that, thank you, everybody, and we'll see you next week.